This is a time where we have unprecedented achievements of humanity globally. It's also a time where we have challenges of enormous magnitude that threaten to undermine all of the achievements that we've had over the past 2 centuries. In the work of the Academy, we've come to the conclusion that the problems that we face today have several common attributes. They are all global in nature. I'm talking about things like the problem of financial stability, the problem of economic development and poverty, the problem of environmental problems and climate change, the problem of security, which we thought after the end of the Cold War was fairly resolved, and now is popping up in new ways, not just military types of security, cultural conflicts, environmental challenges, migration, as we know very well in Europe. So all of these problems have something in common, and that is none of them can be effectively addressed at the national level alone. They all require national level action, but none of them can be effectively addressed at the national level. None of them, we believe, can be addressed individually. That is, there is no solution to the issue of economic problems if we're not going to address the issue of financial stability or ecological issues or security issues, and that goes across the boards. That is, these problems are part of a larger, complex situation that we face as a human race evolving from the local and national level to the global level. And we don't have the institutions, effective institutions or effective policies to deal with these problems at the international level. I think we're all aware that in the economic sphere and the financial sphere, that the crisis in 2008 was largely the result of the fact that we had a wild west of finance where our financial management was at the national level, but we had money moving around the world at tremendous speed and tremendous volumes. We have multinationals acting almost independently of nations, going and acting wherever they find the policies most effective for them. And we simply have not evolved as a species. We have not evolved the institutions necessary to grapple with the rapid pace of globalization. So if the problems are global, the problems are all interrelated with each other, and the problems are extremely complex because of those interrelations. We also came to the conclusion, and this comes to where the work of the Academy is, that the problem is not just that we don't have the right policies. The problem is not just that we don't have the right institutions. The problem is that even theoretically, our theory does not match the reality we're living in. If the policy is not enough, if the institutions are not enough, and if a theory itself needs to change, there's something more fundamental than that, which is the purpose for this course. The further we went into it, we came to the conclusion that there's something fundamental about the way we're thinking about these problems. Not only what we're thinking, but the way we're thinking about them, that is itself part of the problem. And that we need to examine fundamentally how we are using the tremendous capacities of the human mind, and to what extent we are solving the problems through those capacities, to what extent we may be actually aggravating them. When we talk about mind, and we talk about the faculties of mind, we normally associate with that with the capacity to know. But mind also has a capacity to act. We call that will or decision. And very often the discussion focuses so much on our capacity to know that we don't give the same amount of attention to what is it that determines our willingness, our aspiration, our determination to act on what we know. The word thinking itself is so general and used so widely that we have to go to pretty basics to ask what we really mean by that. The mind has the capacity to relate things with one another. Those things may be the sensations we feel when I put my hand in a fire and I think, oh, I probably shouldn't be doing that. That fire has something to do with the fact that I'm feeling so much pain. It has to do with memories that we associate and bring back when we hear something or see something, or when I hear that Linda was at Berkeley at the same time I was. It brings back a lot of memories, makes me think. It has to do with the objects we see or the people we interact with, events, actions, emotions, facts, thoughts, ideas, and all. So as a very simple definition, when we take two or more facts and we relate them to one another, two or more of any of these things, actually, I'm referring to that as a thought. A thought is an attempt to relate, correlate, compare, contrast two or more things within a single formulation. When we take two or more thoughts, which are already one level of abstraction from fact, from reality, from experience, and we try to link those together, we get something that we call an idea. When we take two or more ideas and build on that into a framework, we get something which William Byers calls a conceptual system or a framework. But of course, it can go, or a paradigm, it could go by many names. I'm a fan of 19th century English literature, and one of my favorites is Anthony Trollope. And a repeated theme in Trollope's novels is, what is a gentleman? And is a gentleman determined by birth, or is it determined by status? Is it determined by education? Is it determined by manners? Is it determined by character? And it's quite clear after discussing this and thinking about it for 200 years. No, I don't think anybody in England is quite clear about what a gentleman is either. But it's an example of an attempt to take facts, thoughts, a number of memories, behaviors, appearances, and all these things together and form some kind of a conception about that. That may not sound very scientific, and it isn't, but this is more basic than science or more basic than knowledge. It is the way the mind builds its conceptions. The first line in Jane Austen's Pride and Prejudice is, it's a matter of convention or well-known wisdom that a single man, a single wealthy man who's a bachelor, must be in search of a wife. And the whole story of Pride and Prejudice starts with this idea that if a man is single and if he's wealthy and if he's a bachelor, then he must be in search of a wife, and everybody in the story accepts that, and the story unfolds from that. So this is the way in which the mind puts things together and starts to build its conception of reality. We do that with things like human rights, which is a complex conception built up from an association with many things together. One of my favorite lines in Pride and Prejudice is when the heroine, Elizabeth Bennet, is referring to this very handsome military man, Wickham. She says, any man who's that handsome must be good. And Elizabeth's probably the most intelligent person in the whole story, but clearly it shows that intelligence and knowledge don't necessarily go together when a man is handsome and very flattering. So mind pieces things together and comes to conclusions, not always on a scientific basis. We've taken, it was Steve Wozniak, who was Steve Jobs' partner at Apple in the late 70s, who was the first one who took the microprocessor, hooked it up to a typewriter at one end and to a color picture tube on the other end, and was the first time that anybody ever typed on a typewriter and saw the text coming up on the computer. He saw the relationship between the personal computer was a marriage of some important ideas represented by products. And then, of course, the next step was, you've got the personal computer now. Now you hook it up with communication lines, with the telephone lines and everything, and suddenly you've got a completely different conception, which is the internet. And this is how the mind pieces together reality and builds higher order things. And of course, Einstein did it with E equals mc squared. So our mind has many faculties, and there's no way that we are going to describe them or discuss them all here. We're particularly concerned in this program with how does mind become more creative, more effective at solving the problems and tapping the opportunities we have. So we're not really looking at mind in all of its activities, but how do we enhance the power of mind? The purpose of the video, which I showed you when we started this morning, was to acknowledge up front that it is because of mind and this range of faculties, and maybe you would add many that I have left out here, that have enabled mind to keep building up and building higher orders of knowledge and higher orders of civilization. So what are the fundamental characteristics of mental knowing that are relevant to our trying to become more creative, our trying to overcome the limitations of knowledge or the limitations of our capacity to implement knowledge? First is, our knowledge, what we call mental knowledge, is always indirect. There's really only one thing that any of us know directly without the use of our senses or without even the use of thought, and that is, we can close our eyes and just be quiet for a minute and know that we exist. We don't have to think we exist in order to know it. We don't have to see ourselves in the mirror or look at ourselves to know it. We just know. We have that direct self-awareness. But just about anything else comes to us through either our sensations externally or through a thought, a form that appears to us mentally, which is a thought. It may be a memory, it may be an idea, it may be a fact, it may be anything. But we're always dealing between an intermediary. When Elizabeth Bennet sees this handsome Wickham, she thinks, he's so handsome, he's so pleasant, he's flattering me, he's giving me the attention, he singled me out. I think he must be good. Her knowledge, she doesn't have a direct knowledge of whether he's good or in this case he's really a scoundrel, but she formulates an intermediate thought in the mind and she calls that knowledge of reality. So our knowledge is indirect, and that's one of the reasons why we can be so wrong as she was in that case, and we have many other instances. Our mind creates thought symbols to represent reality, and every thought we have is really a symbol. It's not the reality itself, and that becomes very important when we look at some of the limitations of the way we're using knowledge today. We have a conference on economics next month in Lisbon, and one of our speakers was a former investment banker from Sweden, who has written a book on myth of the market. He's an economist who made millions of dollars as an investment banker before he realized that the whole system is rigged and it doesn't work the way the economic theory says it's supposed to work at all. There's no real competition here. The people who have inside information and inside access make all of the money over the system. And his point was the conception of market, which was taught to him and is taught in economics today, is not the reality of how the market works. It's a conception. It's just a symbol. And when we look at why our knowledge isn't working, we have to ask ourselves, in what measure is it because we don't know how to act on it? In what measure is it that the symbol is really not matching the reality. These are some of the issues we'll be discussing. Third, when I speak, I have 100 ideas that want to come out all at once, but if you're going to understand anything from me, it's got to be a linear sequence of words and a sequence of sentences, and that's the way we think as well. We think in terms of linear order of words and everything, but the reality that we're trying to grapple with, which was made very evident by Tibor's presentation this morning and other comments, and Alberto's and others, is the reality we're trying to deal with is multidimensional and complex and interrelated. It doesn't lend itself so easily to following it by a linear process, but that's the way our minds work. Our mind, one of the fundamental capacities of our mind is we know things by dividing reality into parts and taking each part as if it's a whole, and then dividing that whole into smaller parts and subdividing it into smaller and smaller parts, and concentrating on each of those parts, pushing everything else out of the way, which of course is what we're all doing this morning, being here in this session. We're forgetting, hopefully, our family obligations and problems that may be there elsewhere, what we're going to do yesterday, what we did yesterday, or what we're going to do tomorrow, or how we're going to solve the greatest issues in our lives. We focus and concentrate on a part as if it exists as a whole in itself, and we try to know that. But then we try to compensate for the fact that having done this, we've divided reality up into so many parts. By latest count, there are more than 1,000 sub-disciplines of knowledge taught in American universities, which gives you an idea of, and all of you from whatever field you're in, you can count the number of disciplines and sub-disciplines there are. But we also know that's not enough, and so we try to do something to put reality back together, to aggregate it back together, to reconstitute a whole, and mind has the capacity to do that in some ways or another. The question, one of the fundamental questions is, to what extent does a division into parts and an aggregation back into a whole really give us reality? We get something for sure. We get conceptual systems for sure, but does it give us reality? And that's one of the main themes I want to address this morning. We tend to take these little pieces we've cut out and construct concepts or conceptual systems out of them. And I'm purposely not passing judgment on this at this time, though I want to comment, but I'm trying to just look at the basic characteristics of the typical way in which we think. One of the things we also do, we not only divide reality up into parts, but we also tend to separate ourselves from the reality that we're studying. That's the Cartesian separation. We tend to we're talking about mind now as if mind is something different than us. Thinking is something different than us, something out there that we can deal with in an objective way, separate from ourselves. And that raises fundamental questions about the relationship between the objects we try to know and our own subjective consciousness, which is a main theme of this program, which I've come back to. And finally, of the list I've chosen, in our acts of concentration, mind has a tremendous power to concentrate. We are all talking about a particular subject now, a particular moment in time. We do that not only by dividing it from everything else, but by literally forgetting everything else for a moment. We limit our field of knowledge to something, and then we get so absorbed in the thing that we're trying to know that we virtually forget, consciously forget, that which is interfering with our capacity to concentrate on a part. All of these characteristics, I think, have a profound impact on the kind of knowledge we're very effective in developing and the limitations in the knowledge we develop, which is the theme of my talk. I'm just going to make a distinction between three types of thinking: analytic thinking, what I'm calling synthetic thinking, and integral thinking. And those of you who had an opportunity to read the background paper, you've already gone through this, and I'm just going to do it briefly. The analytic thinking is that use of the faculty of mind to divide reality up into smaller parts and subdivide it into smaller and smaller parts. The periodic table, which we saw on the video, the list of the animal phyla, many examples we have illustrate what analytic thinking is. And I'd like to be clear up front. Analytic thinking has been a tremendous power for the advance of civilization, because it probably was the only way we could start, was to start with the part and develop knowledge of it and gradually piece things together. And it's responsible for our knowledge of the atom, our knowledge of chemistry, our knowledge of the structure of molecules, of the varieties and differences of species, of genetics, physiological processes, computer programming, and artificial intelligence, and so forth. So I'm not trying to say that we should not use the capacity of analysis. It's a tremendous power. But I would say that this has been the dominant power we've been using for the 400-500 years. And one of the reasons for the video this morning was to show in the history of our civilization, the intense focus on analysis has only been for a short period. We are in it now. It's been until middle of the 20th century, it was at its peak. Now we see some change going on. But all the great advances of what we call science and technology largely have been the result of that up until recently. And I think all of the limitations or unanswered questions or problems are also a result of the fact that we've been using one faculty very intensely to the exclusion of a much broader palette of capabilities. So, limitations of analytic thinking. I think you're all familiar with them. I just put up one example here. If you want to really analyze the human body and get it down to its basic constituent elements, you can say we're 57% water, we're 10% hydrogen, 18% carbon, 65% oxygen, and so forth. And how much do we really know about the human body when we can get this list down and list every mineral and element and know our exact percent? We do know something. It is a knowledge to know that water is it's more than half of our body. Naturally, we need a lot of it, and that's why we're bothering with it. But in knowing that knowledge, how much knowledge is lost? How much knowledge is rather ignored or outside the purview? And this is one of the characteristics of analytic attempts to know. It reduces the complexity of reality to basic constituents. It tends to fragment knowledge into small parts or categories. It divides different fields so that we get more and more fields. It tends to construct, if you construct a model of the human body based on its basic constituent elements, you get a real conceptual framework, but how much does it really represent the complexity of what the human body is? Whether it's physiological complexity, anatomical complexity, or the utility and capacities of it, or the fact that it's a living organism, or the fact that in our case, it's got a conscious head, a conscious mind connected with it. None of that comes out when you look at its constituents. So we tend to get models of reality that looked at from one point of view are entirely or appear to be valid, but in the very process of validating themselves, omit so much information, omit so much of the reality. maybe we'll come back to this, but I recently read a book by Herbert Weinberg. He's a statistician, a very interesting book in which he argues that the very act of using statistics involves what he calls willful ignorance. The statistician knows that there's so much of important information about reality, but the statistician is looking for those things that can be measured and generalized. And so in order to focus on the commonality of what we all have in common, if we want to get some statistics of this group, we can get it by age or weight or occupation or education or so many things. And we think we may have a nice framework of, we know the kind of people who were in the room, but how much is left out by those statistics? Just about everything that we individually consider important and real that makes us who we are. So this is a characteristic of analysis in general. And his argument was that clinical, what's happening today, he's applying statistics in the field of medicine. More and more, the statistics are being taken for the reality, and the clinical expertise is being eliminated, and the statistics are being used not only for diagnosis, but also for prescription, leaving out the fact that the clinician has a personal experience of the patient, knows the temperament of the patient, the history of the patient, the understanding and attitudes of the patient, and can take all that in mind, but the statistic is just prescribing based on some general parameters. So this is one contribution. We all know this, and I think this is nothing new, but particularly over the last 7 decades, there has been an emphasis or an attempt to compensate for the limitations of analysis, not by eliminating it, but by doing something to compensate for it. And this is what I mean by using the capacity of the mind for aggregation. We not only can divide, but we can aggregate. And so it goes under various names, commonly systems thinking, holistic thinking, ecological thinking. I'm using the term synthetic thinking. We try to put together all these things which have been divided and create a framework which shows their interdependencies and tries to image the whole. And this too has been a tremendously fruitful effort of mind. And when we keep in mind that this type of systems thinking was really very rare before, let's say, 50, 70 years ago, in the heights of the analytic movement, and how much we're changing, to me it suggests that if we've moved this much, there's no reason we can't move further. If we really recognize both the advantages of systems thinking and limitations, which I want to mention, we have an encouragement to think. Mind has developed so many faculties. We have used them in the past. We have developed our civilization based on them. And if the current combination we're using is not fully giving us the results we need, let's not only look for external reasons for that, but let's also look fundamentally, are there other mental capacities that can help fill the gap? So systems thinking, the achievements of systems thinking, I don't need to spend time on it. We're all familiar with it. And we're using today the fruits and results of systems thinking in everything we do. It's leading edge in science today and in development today. This is a map from Wikipedia that traces the development of complexity science and systems thinking over the last 50 years. And it shows how it's been branching out and developing. Systems thinking has one, I think, very important advantage over the analytic thinking, among others, is that some of the systems thinking takes us away from the disciplinarity, not all of it, but it enables us to look at things across disciplines and find some fundamental principles that are common to many, many different disciplines. So whereas analytic thinking, it's very hard to do in a really effective cross-disciplinary or transdisciplinary way, systems thinking creates that possibility, and these are a few examples of where we see that happening today. If you take a simple example like management, I mean, principles of management are applied in everything from business to education to government because there are common principles that even to family life as well. And I just mentioned some of the common transdisciplinary principles that are prominent in systems theory today. But I would argue that it also has limitations, not inevitably necessarily, but in practice, this is what I see recurring over and over again. Most of what goes under the name of systems theory, even when it's dealing with living systems like ecological thinking, tends to compress and regard all reality as if it's in one plane, that is, it's all physical, and everything that's to be mapped in the system is physical, whereas the discussion this morning, both Alberto's comment and Tibor's comment, made it really clear that it's not the physical determinants alone that are determining how anything happens in the world, but most systems thinking stays in one plane, and it tends to be mechanistic, even when it's highly complex, highly interactive, highly interconnected. It still tends to look at reality in a mechanistic way. It looks for how can we reduce complexity to rules and common principles still. And each time we put a chart within the system, we're looking for a generality of it. And there's nothing wrong with that. It's valuable. But my argument is it leaves out some critical dimensions. The two things that I think it leaves out very much are, one is the whole subjective dimension, which Tibor and Alberto mentioned, and we have a whole session devoted to the validity or the role or the proper place of subjective experience in knowledge. Not just in our lives, but in knowledge. What is the value of knowledge when it denies or ignores the subjective dimension? And systems thinking does still tend to do this, by and large. And equally important, it tends to ignore the role of the individual. It's still looking at generalities. And this is another fundamental. We had a whole course. Our first course here was on the role of the individual in society. Systems thinking still seems to think of society as a system in which it looks at the generalities that are valid, but we live in a world in which one person can change the world. Maybe change it for better or change it for worse, as Tibor had in mind with a few of his unexpressed examples this morning. One or a couple of men, Steve Jobs and Steve Wozniak, whether we like it or not, definitely changed the world disproportionately to their size or resources or anything, and we see that in every field. So if we're looking for a knowledge that is really complete, we're going to have to find a way to reintegrate the subjective dimension and reintegrate the individual dimension. And systems thinking, I have not seen that it's really effective for that. So where I'm really going is to talk about another level of thinking, which I'm calling integral or organic. It doesn't, the words you can use whatever you feel most comfortable or descriptive with. You can also say that systems thinking recognizes that there's a whole that's greater than the sum of the parts. But again, it tends to be more of a unidimensional whole. I'm talking about a whole that would integrate the objective and the subjective dimensions, would integrate the individual and the collective dimensions. And you're going to hear in this session, one of our panelists who's not here, he's in India, is Chandrasekharan, and he's going to talk, I think, about health. And so I'm not going to preempt that, but it's a really good example. If we think about what our concept of health is, do we have an analytic concept of health? Do we have a systems concept of health? Or do we really have an organic, integral concept of what health is? I think they are three very different things. And the example will help us really elaborate on it. Well, integral thinking, I put up these concepts just to indicate clearly. These are, to me, very important things in life. Health is important, happiness is important, life itself is important, mind, society, personality. None of these, with all the knowledge we have, can we say that we have a valid definition or conception of what any of these things are? I don't think that any of these things, which are fundamental to reality, that was kind of the slide we put up at the beginning of the video, and then put it up again at the end. What were the things that we were really looking for, and what have we found, or what are our questions? On the fundamental issues, how do we create harmony in society or in ourselves? What is peace? Is peace really the absence of war, which is a kind of analytic thing? If you take away that, this, and all the things that disturb, then you've got peace. Or is it something positive? Is it a positive conception? None of these fundamentals really lend themselves to an analytic or a systems definition. And I would argue, in psychology, that's very true. When we try to ask what is human personality, it completely defies. You get all the theories of personality that are analytic, and you get systems-based theories, but when you really try to get down to what is personality, it defies that type. So are we destined never to have an answer to that question? Or are there faculties we can develop that will help us arrive at that answer? And we don't have to invent something new, but as in the past, we probably have to develop something that hasn't been very well developed in recent times. Whether you call it insight or intuition or any other word that you want to call it. In our marketing for the program, we advertised this on the web, and we got some 300 people registering for the course. And we had my staff created a video for that, and they included 4 quotes about intuition, all of them by most eminent scientists like Einstein or Karl Popper, the philosopher of science, all of them saying the same thing, that great scientific discovery doesn't come by a linear process, doesn't come by a rational process, it comes by something else. It comes by something that they all use, for want of a better term, intuition. And yet in the practice of science, in the study of science, in the teaching of science, in the research on science, we research all about the methodologies for validating knowledge, but hardly give any attention to the faculty which is really creating the new insights about it, as if, well, that's something we can't discuss. Is it something we can't discuss because intuition is some nameless, formless, nebulous non-reality? Or is it because intuition doesn't lend itself to knowledge by analysis or even by systems thinking? It requires a different development of a different faculty. This is a formula from the Upanishads some 4,000 years ago. Obviously not arrived at by analysis or systems thinking. We had it in the video under the topic of the seers, who saw that a fundamental truth of reality is when you stop cutting things up and stop trying to aggregate them together, the truth is that everything is related to everything else. And that means complexity, and that means it's very difficult for us to handle it piecemeal. It's very difficult for us to schematically draw it or categorize it. But if that's reality, then we have to ask ourselves, does mind have a faculty capable of getting closer to that reality, of expressing that reality? Has it shown in cultures of the past? Is it something that was rare in the past, but may be more common in the future? Clearly, that's not what we're trying to develop through our educational system. So it shouldn't surprise us if that's not what we're getting, if we're not all being born intuitive. 500 years ago, if you could read and write, you were qualified to be a genius. Today, if you can't read and write, you can finish the sentence. In 1860, there was one PhD awarded in the United States. By 1980, it was 55,000 in 1 year. But at that time, in 1860, if you were a PhD, you were a genius, because they didn't exist. So is it possible that a faculty which we think of so nebulously, we don't even really study it, we don't understand it, is it possible that it is one of the faculties, it's been developed in the past or not, but it is a capacity of the human mind, otherwise we wouldn't have people having intuitions and we wouldn't be having the benefit from them. Isn't it worth trying to understand more about what it is and look at our educational system and see, are there ways that we can be encouraging that, not to reject other faculties, not to stop memorizing, remembering things or imagining things or analyzing them or synthesizing them, but to complement and complete and make more whole the knowledge we have.